Let's solve question 101. This is a question from similarity. In the given figure, BC is parallel to EF, CD is parallel to FG, AE is to EB is 2 is to 3, and angle BAD is 70 degree, ACB is 105 degree, ADC is 40 degree, AC is bisecting angle BAD. Then first we need to prove that triangle AEF is similar to AGF. So if I look at these triangles AEF and AGF, already I know that AC is bisecting angle A. So this is 35 degree. This part is also 35 degree. So in these two triangles, I have one pair of equal angles. If I'm able to prove another pair of equal angles, then my proof is done. So for that, if I look at triangle ACD, I have D as 40 degree, this is 35 degree. So then according to angle sum property, this angle will be 180 minus 40 minus 35, which is 105 degree. Now if this is 105 degree, even this angle, which is AFG, must be 105 degree. The reason is CD is parallel to FG, so these two angles are forming corresponding angles. Even BC is parallel to EF, so if this is 105 degree here, angle AFE must also be 105 degree. Therefore, in these two triangles, I have two pairs of angles which are equal, therefore they must be similar. So you can write the steps something like this. So in these two triangles, these are the pairs of equal angles for the reasoning that were explained now. Therefore, AEF is similar to AGF according to AA similarity. Done. In the next part of the question, they're asking us to find the ratio AG is to AD. AG and AD. Okay, so let's start with AE and EB. It is 2 is to 3. EF is parallel to BC. So in triangle ABC, if I apply basic proportionality theorem, I can say AF by FC should be equal to AE by EB. So AF by FC is 2 is to 3. Then similarly in triangle ACD, FG is parallel to CD. So AF by FC must be equal to AG by GD. So AG by GD is also 2 is to 3. But they're asking us the ratio AG is to AD. So AG is 2 units, AD is 5 units, AG is to AD will be 2 is to 5. So you can write it like this. That in the triangles what are parallel and the ratio of sides you need to write, and the theorem is basic proportionality theorem. So therefore the final ratio AG is to AD you can say is 2 is to 5. Then moving ahead, we are looking at ratio of areas. So they're asking ratio of area of ACB is to ACD. ACB, ACD. Okay. Now looking at all the information given to us in ACB and ACD, I have these two angles equal 105, 105. AC is a common side, and even angle BAC and DAC are equal 35, 35 degree. So I have a pair of angles side and another pair of angles. According to angle side angle, the triangles ABC and ADC are actually congruent. Now, since the triangles are congruent, I know that areas of congruent triangles are equal. So the ratio of areas of those triangles should be 1 is to 1. So you can write like this, that in triangle ACB and ACD, we are able to find out that they are congruent according to ASA. Therefore, I will say ratio of areas is 1 is to 1 because congruent triangles have equal area. Then let's look at the ratio of area of quadrilateral ABCD is to area of triangle ACB. ABCD, this concave quadrilateral, is actually the sum of triangle ABC and ACD. Now I have proved that ABC and ACD have the same area, let's say x units, x units. So the full quadrilateral will have area 2x units. Therefore, area of quadrilateral 2x, area of triangle is x. So the ratio should be 2:1. So you can write it that way, that area of quadrilateral is sum of the areas of the two triangles, and the two triangle areas are equal. So therefore the ratio of quadrilateral to triangle should be 2:1. Moving ahead to the next question. This question is from circles and tangents. Okay. In the given figure, angle ABC is 70 degree and angle ACB is 50 degree. O is the center of the circle, PT is a tangent. Then we have to calculate these four angles. So first is angle CBT. So I can join BT. Now I have O as the center of the circle. So CT passes through the center. So CT must be the diameter. If CT is the diameter, I have a semicircle. So angle CBT is an angle on the semicircle, which will be 90 degree. Then for angle BAT, you can join AT. Okay. So for BAT, you can look at in triangle ABC. I have 70 degree, 50 degree. So the remaining angle, which is angle BAC, must be 60 degree according to angle sum property. And also, if I look at angle CAT, CT again being the diameter, CAT should be 90 degree. So BAT is 90 minus 60, which should be 30 degree. So BAT is 30 degree. Then for PBT, PBT is same as ABT. And if I look at ABT, ABT is actually CBT minus this 70 degree. CBT was 90, this is 70, so this is 20 degree. So ABT is 20, so even PBT must be 20 degree. Then finally, for angle APT, I can look at ACT and ABT as equal angles because they are in the same segment. Okay, so ACT is 20, then BCT must be 50 minus 20, which is 30 degree. So if I'm looking at this angle 30 degree here, I have, let's call this point as some point like Q. So I have a triangle BCQ in which I have angle B 70 degree, angle C is 30 degree. So angle Q according to angle sum must be 180 minus 70 minus 30. So angle Q is 80 degree. Then if I look at angle PQT, it is vertically opposite to this other angle. So this is 80 degree. And PT is a tangent, OT is a radius. Tangent and radius are perpendicular. So if I look at this triangle QPT, I have 80 degree, 90 degree. So then this angle 180 minus 80 minus 90 will be 10 degree. So this is 10 degree. So the complete solution I have written over here like this. First part is that angle CBT is 90 degree, angle in a semicircle. Then from triangle ABC, I am finding BAC as 60. So BAT is CAT minus CAB, 90 minus 30, 90 minus 60, which is 30 degree. So part A, part B. Then for part C, ABT angle is CBT minus CBA, 90 minus 70, 20 degree. And PBT is same as ABT, which is 20 degree. Then for the last part, ACT and ABT were equal angles because they are angles in the same segment. So ACT is 20 degree. BCT is ACB minus ACT, 50 minus 20, 30 degree. Then in triangle BQC, I have labeled one point myself in the figure as Q. So according to that, triangle BQC, angle BQC will be 180 minus 30 minus 70, which is 80. Then PQT is same as BQC, which is 80, because they are vertically opposite angles. Then in triangle PQT, if I apply angle sum property, angle QPT will be 10 degree and APT is same as QPT, same as 10 degree. This is just one way to solve it. There can be many ways that you can solve the same question, but you'll get the same answer. Moving ahead, we have a construction question. Use a ruler and compass. First, construct a triangle ABC such that BC is 8, AC is 10, and angle ABC is 90 degree. Then you have to construct an incircle to the triangle. Mark the center as I. Write the length of the in radius. Measure and write length of in radius. Measure and write length of the tangents from vertex C to the incircle. Mark points PQR where the incircle touches the sides ABC, AB, BC and AC. Write the relationship between angle RIQ and QCR. So reading this description, you need to first draw a rough figure to understand what is happening. So according to the question, you have to first construct a triangle ABC, which is a right angle triangle as per the question. Okay, so you can first think of taking BC as a line segment 8 centimeter. Then at point B, draw a right angle. AC length is given as 10. So from point C, you can take 10 centimeter in your compass and cut off 10 centimeter from point C till this perpendicular line. That will give you point A. Or otherwise, you can also think of using Pythagoras theorem. If BC is 8, hypotenuse 10, then AB length should be 6 centimeter. So that way, you will be able to draw triangle ABC. Then to construct incircle, you must first locate the incenter. Now, incenter is located on the intersection of the bisectors of the angles of the triangle. So you can draw bisector of any two angles. For example, let's draw bisector of angle B and angle C, and let's say they intersect at this point. So this point you can label as I, which is your incenter. Then after you have figured out what is your incenter, you need to draw a perpendicular from the incenter to any one of the three sides of the triangle. So you can draw a perpendicular from point I to, let's say, side BC, and let's say IQ is perpendicular to BC. Then take the compass, center at I, radius as IQ, you draw this circle. You will get your incircle. And then they have asked you to take the measurement of the radius and some tangents that you can take. And then finally, you have to tell the relation between angle QIR, this angle QIR, and angle QCR. So that relationship you can theoretically also think, because let's say you have triangle IQCR, angle Q and angle R will be 90 degree. Radius and tangent are perpendicular. So I have two angles which are 90 degree, 90 degree. Angle sum of a quadrilateral is 360. So therefore the remaining two angle sum should be 180. So that's the relationship that you can write between these two angles. Now let's start with the construction. Take a scale and draw 8 centimeter length. So label it as BC. Then at point B, you have to draw a 90 degree angle. So point A must be located somewhere here, and the length AC is 10 centimeter. So you can take 10 centimeter radius in your compass. So point C and cut the 90-degree line over here. So this is point A. Join AC. AB will be 6 centimeter according to Pythagoras theorem. This is 90 degree. This is 10 centimeter. Okay. Then you need to draw bisector of any two angles. So let's bisect this 90 degree angle B. Take any radius, center over here, and draw an arc somewhere here. And then with the same radius, center over here, cut the previous arc. Then join these 2 points. This is bisector of angle B. Then let's bisect angle C. So with some radius, you draw an arc cutting the 2 arms of the angle. Then center here, draw an arc here. From center here, cut the previous arc. So it cuts the previous arc at this point. Then join these 2 points. Alright, so we see that these two bisectors, these two angle bisectors intersect at this point. So I will label this point as point I. Now from point I need to drop a perpendicular to any one of the 3 sides. So let's say I'm drawing a perpendicular to side BC. So I'll take my compass, center at I, and some suitable radius so that I can cut the line BC at 2 points. So if I draw an arc, I can cut the line BC in 2 points. Then from both the points, you draw arcs on the other side and try to intersect the 2 arcs. Try to cut the 2 arcs and find the point of intersection. So this is the point of intersection. Join this and point I. So this is perpendicular. So this point over here, the perpendicular which cuts the side BC, this you can label as Q. So IQ is your in radius. So then take your compass at center I, take radius as IQ, and you can draw a circle. So you will see this circle is the in circle. Okay, so the circle is touching the sides. Let's say this is point P, this is point Q, and somewhere here we have point R. So we have PQR. Then they asked us to measure the in radius and the length of the tangents from vertex C to the in circle. So one is in radius. So IQ is in radius. If you measure, it is about 2 centimeter. So I will say that my in radius is about 2 centimeter. And then tangent from point C to the in circle. Suppose it is one length is CQ. If I measure CQ, I'm getting about 5.9 or almost 6. So I can say that length of tangent CQ, and that should also be approximately same as CR. That should be about 5.9 centimeter. So let's check the answer quickly. Answer given for 103. So they are saying in radius they are getting 2 centimeter, length of the tangent 5.8. If we write 5.9, that's also fine, it's close enough. And the angle, yeah, we have to write relationship between angle RIQ and angle QCR. Like I mentioned before, these two angles will add up to 180 degree. Angle RIQ plus angle QCR is 180 degree. You don't need to measure it, you can theoretically find that.